Okay, friends, this is your first video lesson of the exponential functions unit, and there are two quick little skills we're going to work on in this assignment. So the first one is just recognizing when a function is exponential versus when it's one of the types of functions that we're already more familiar with. So the first thing I want you to do when you look at these three functions you see in front of you is figure out which function is linear. And you're going to do that by looking at how the function is changing as x changes. Okay? So, and you can pause the video if you need to do that. I'll give you just like one more second. And you should have said that that middle function is linear. Okay? And the way that I know that and the way that you know that, right, is that as x increases, we add 7 to y. So each increase in x leads to an increase of 7 in f of x. That tells us it's a linear function with a slope of 7, right? So we label that one as linear because it's an additive relationship, right? As x increases, I add to y. Okay. And then my exponential function, if linear is an additive relationship, exponential function is a multiplicative relationship. So I'm going to add that to our notes up here. So what that means is when you look at our left-hand function, it's this, right? So 40 times 2 is 80, times 2 is 160, and so on, right? So each increase in x means we're multiplying the previous y by 2. So this is an exponential relationship. And you guys studied these last year in Algebra 2 at least a little bit. So this shouldn't be totally new to you. So this first skill is about recognizing patterns, right? And like, I think you guys are honors math students. Part of the reason that you found your way into honors math in the first place is because your pattern recognition is probably good. So you should have an easy time with this. The last type of relationship, and you can guess for my options here, is a quadratic relationship. So this last one is quadratic. And this is kind of interesting. So the first thing you should notice here is that the rate of change is not constant, right? So I'm not adding some constant slope, right? But I'm also not multiplying by the same number each time, right? And that makes sense based on what we know about a parabola. They start very skinny and they kind of get fatter as they go up, right? If we look at what's being added each time, if we assume there's some sort of additive pattern, let's see what we get. We have plus 7. We have plus 9 to get from 16 to 25, right? And then we have plus 11. And then we have plus 13. So you should recognize that it's hard to see the pattern in the change in f, but it's easier to see the pattern in the change in f, right? So notice my rate of change increases by 2 each time. So the rate of change in a quadratic is increasing as x increases. And that's a phenomenon we're going to study more next year in calculus. So if you found that interesting, it's probably something you did not know about quadratic equations. We'll study more on that next year. Okay, so your first mission is just to classify these. The other option is not a function, so be on the lookout for that as well. Remember, not a function means if an x shows up more than once with a different y, that's going to be not a function. Okay, we're going to move on now to the meat of the lesson here. So now's a good time to pause and just make sure you can articulate the difference between these three things. And then we're looking at writing exponential functions. So exponential functions take the form, and we're going to look at this example down here. The form of our exponential function is f of x equals a times b, I'm going to make it lowercase actually, a times b to the x. Okay, and this is sort of like you're similar to like your y equals mx plus b form, right? So a is going to be your starting value. And what I mean by that, it's sort of like your b and y equals mx plus b. So starting value. So f of a, or what should I say? F of 0 is what gives you a. So, and that makes sense, but based on what we know about our exponents, if it's a times b to the x, right? If I plug in 0 for x, b to the 0 is 1, because anything to the 0 is 1. So a times 1 is a, right? So that makes sense. And we can get that number from the table, right? So here, f of 0 is a. And then b, sometimes we call it the base, because it's the base of the exponent here. Some texts and some teachers call it the common ratio. So that's a good word to know as well. I'm more concerned about whether you can set it up than whether you know all the words. But it's a good word to know. And if you think about really like the words common ratio, it's pretty easy to guess what that might mean. So common ratio is sort of like your slope. But because it's a multiplicative relationship, it's what you're multiplying by for each increase in x. Okay. So notice this one, and this is a different type of exponential equation than we've seen before. This one's decreasing each time. So as x increases, y gets smaller. Right? What that means is we're multiplying by a fraction, and here we're multiplying times 1/2. And I could divide 1.5 times 3, or divide by 3 to get that, right? So that's my base, right? Times 1/2 for each. So my equation, and I'll use x and y because that's what's given in my table. My equation in this case is y equals a times b to the x. So a is 3. And then my base is 1/2 is what I'm multiplying by. So 3 times 1/2 to the x power. And that is it. So that's everything you need to know to complete the 1.1.1 Delta Math assignment. As always, let me know if you have any questions. If you're struggling, I bet for this lesson especially, you'll be able to figure it out if you come back and rewatch the video. So keep in mind that that's an option too. Good luck.